Okay, let's give you guys some practice now. So find the directional derivative of this surface at this point in this direction. So what that means is you've got your surface here. You've got your surface here at this point. So so you've got your XY plane. You've got your XY plane. The origin is somewhere in the middle here. At this point here, one across in the X direction, 2 across in the Y direction, 1, 2. Let's just imagine it's somewhere here. And then looking at this direction, this vector, 3 across, 1, 2, 3, 5 across, 1, 2, 3, 4, 5. Let's just say it's somewhere around here. So now you've got to draw your straight line. Draw your straight line. Hang on. Draw your straight line. And then, so you could imagine this vertical sheet of paper here, where the vertical sheet of paper intersects with the surface. Work out the gradient of this thing here. Work out the gradient of this. So overall, find the directional derivative of this function at this point in this direction. So press pause and have a go. Okay, so to do this, the directional derivative at this point is given by the dot product of the gradient vector with dotted with the unit vector. So looking at our vector, this is not a unit vector, so we've got to convert this into a unit vector. So converting into a unit vector, get our vector divided by its magnitude. Its magnitude is root 34. So our unit vector is given by this. Now we've got to work out the gradient vector. Well, remember, the gradient vector is given by this, by you taking the partial derivative with respect to x. So looking at our function, take the partial derivative with respect to x. So that will then give us this thing here. And then looking at, and then we need to take the partial derivative of the whole function with respect to y. That will then give us this thing here. So you might have to pause and think about it, but take my word for it. It equals this and this, and we need to evaluate it at that particular point. We need to evaluate it at the particular point of 1, 2. So that will then give us this thing here, 3/25, and evaluate it at this point here. That will then give us this thing here. So now we've got our gradient vector. Our gradient vector is given by this. Our unit vector is given by this. So if you want to know the gradient at that particular point, at this particular point, just take the dot product of these two vectors. So the dot product will be this times this, and then plus this times this. So that will then give us this. Merging the two together, that will then give us this thing here. So the steepness at that point in that direction is this thing here. So that's done. So we're done with that example. But just to give you a side note, we've got our surface. If you want to know, if you look at the level curve at that particular point, it will look something like this. And so the oops, hang on, bear with me. Bear with me. Alright, if hang on, let me go back one step. So we're here at the moment. If you want to know the gradient, at that particular point, it is given by this. So now at this point here, if you look at the level curve at this point here, it will look something like this. If you look at the level curve at that particular point, it will look something like this. So if you want to draw a tangent line across here, well, grad f is given by this. So that's this vector here. That's grad f. So this is your grad f. And notice that it's always perpendicular to the level curve at that particular point, at 1, 2. So this is at 1, 2. So so grad f is given by this. If you want to know the tangent line, well, if you look at what is the gradient of grad f? Well, the gradient of grad f, the up and down is this thing here. The up and down would be 4/25 negative, and then the across here would be this thing here, 3/25, and so that's a gradient of grad f. That's the gradient of grad f. But if you want to know the equation of the tangent line, you need to know the equation of the tangent line. Does that make sense? If you want to know the equation of this line, you need to know the gradient of this tangent line. So so tidying this thing up, that will then give us, hang on, that will then give us, hang on, 25 times 25/3 negative. So at the moment, the gradient of grad f is negative 4/3. So that's the gradient of grad f. If you want to know the gradient of the tangent line, you need to take the negative reciprocal of this. So let's take the reciprocal. It will be the negative, the reciprocal of that. So that would then be this. So that will then equal 3/4. So the gradient of our tangent line is 3/4. So the gradient of our tangent line is 3/4. At that particular point is 1, 2. So I'll put this into here, put the 1 into the x here. That will then give us this thing here. Well, the equation of that tangent line is given by this. So so if you jump to a graph plotter and plot everything in, the level curve at that particular point is this red line here, which is this thing here. So so to get the fifth here, you put 1, 2 at that particular point, 1, 2. You put 1 into here, you put the 2 into the y. That would give you a level. This thing here will give you this level curve here, and then grad f is given by this. So that's grad f there. That's that vector there. And then from grad f, you know the gradient of grad f, so you can work out the gradient of the tangent line. If you know the gradient of the tangent line and it passes through this particular point, then you can work out the equation of that tangent line, which is given by this. Okay.